Hi everyone and welcome to our PHY380 video assignment project. Today we will be exploring a fascinating infrared technology known as thermography, a method that lets us visualize heat and temperature using infrared imaging. So I will introduce our group members, me, myself, Anis Fatin Zulaika binti Muhammad Fikri, Muhammad Ikram Muaz bin Shamsul Azman, and Nur Alia Sofia binti Zulkifli.
What is infrared radiation? Infrared is a type of energy called electromagnetic radiation. It has a longer wavelength than a visible light, which means we can see with our eyes, but we can feel it as heat. For example, when you feel warm from the sun or heater, that is infrared radiation. Most things around us give off infrared. Even though it's invisible, we can use special tools like thermal cameras to see infrared. What is thermography? Thermography is a technique that uses infrared imaging to detect and measure temperature difference on the surface of objects or within a body. Thermography relies on the principle that all objects emit thermal energy. Thermal energy refers to the infrared radiation emitted by the object based on their temperature. The infrared radiation captured, which represented as a thermal image, is emitted and absorbed in a greater or lesser quantity by all things. So how does the thermography work? First, these cameras are equipped with infrared detector that can detect the heat signature of objects in the form of thermal patterns. It captures the thermal energy and sends the data to special software which focus infrared energy to a sensor array or a detection chip with thousands of pixels in a grid. Next, temperature variation. Objects at different temperatures emit different levels of infrared radiation. Hotter objects give off more heat while cooler ones give off less. Each temperature is given a different color. Then comes image processing. The software turns the heat data into a picture or video that appears as a different color. Hot areas look brighter such as white or yellow and cool areas look darker such as blue or black. This diagram shows how the infrared thermography works. The infrared thermography works by detect the heat from an object. First, infrared radiation is given off by the object. This invisible heat passes through the air, then enters the infrared camera. Inside the camera, the process begins. Number 1. Scanning. The camera scans the infrared radiation. Number 2. Condensing. The signal is focused. Number 3. Detection. The heat is detected and measured. Number 4. Amplification. The signal is made stronger. Number 5. Display. The final image is shown on the screen. The system also includes the synchronizing, which keeps everything working in order. The camera changes the infrared energy into temperature data, then turns into a colorful thermal image. Next, the significance of the thermography. Number 1. Contactless and non-destructive. This means thermography checks heat without touching the object. This means no damage to the item being tested. Number 2. Real-time inspection. It shows the temperature changes instantly. Problems can be found and fixed quickly. Number 3. High quality and reliability. It sees heat that our eyes can't see. This helps find hidden issues and improve the inspection. Number 4. Full mapping. It checks it checks the whole object or area. You can easily spot any unusual parts or defects.
Now, let's take a look at on the explanation of relevant to scientific instrumentation concept. Before that, we must know what is infrared thermography. Infrared thermography is a technology that uses infrared detectors and lenses to capture the heat emitted by any object and convert it into a visible image. How infrared thermography works. The core part is the infrared sensor, which is microbolometer that absorb infrared radiation and changes electrical resistance based on heat. The sensor data goes through an analog to digital converter ADC to produce a digital thermal image. Last but not least, infrared thermography links integration with the other system, such as thermography can be combined with AI image processing software to automatically detect faults. For example, many industry systems integrate thermal camera into drones or robots for hard-to-reach area. Next, we must know that there are important parameters in scientific instrumentation concept of infrared thermography. The first one is emissivity. Every material emits infrared differently, such as shiny metal have low emissivity. So, the camera must be adjusted to avoid errors. The second one is NETD, which is noise equivalent temperature difference that describe how small a temperature difference the camera can detect. Lower NETD means higher sensitivity. Last but not least, field of view (FOV), the area the camera can cover in one image, which is it important for inspecting large equipment or buildings. Now, let's move on the explanation of relevance to scientific application thermography concept. The first application is non-destructive evaluation (NDE). Unlike X-rays or ultrasonic tests, thermography does not require contact or shutdown of equipment, which is it's safe for live high voltage systems and delicate medical checks. The second application of thermography concept is data logging and trend analysis. Now, modern thermal cameras store images and temperature data for comparison over time. This concept enables trend tracking. For example, is a motor getting hotter over a month? Or is insulation wearing out? Last but not least, the last concept applications in thermography concept is remote and automated monitoring. Thermosensors can be installed permanently for continuous monitoring that used in critical systems like power plants or server rooms to trigger alarms when temperature exceeds safe limits. Let's move on the detailed exploration of thermography. But before that, we must know why nowadays industrial choose and use thermography in their applications concept of instrumentation. The first one is thermography can detect problems early before they can cause failures. Other than that, thermography also can perform inspection safely from a distance. Thermography also can monitor large or hard to reach area quickly, and it also provides evidence with images for reports, maintenance record, or diagnosis. There are some examples where major fixed thermography is applied. The first one is industrial predictive maintenance. The second one is medical thermography. The third one is building diagnostics. The fourth one is fire and rescue operation. And last but not least, security and military. So, in this slide, we will explore in the detailed exploration on the application or technology thermography. Just like I told earlier, there are many major fields that use thermography in their instrumentation concept. The first one is industrial predictive maintenance. Industrial predictive maintenance is a large factories that uses handheld or mounted thermal cameras during routine inspection. For example, in a manufacturing plant, an electrician checks switchboard weekly. If one breaker appears 20 degrees Celsius hotter than the others, it will likely has a loose connection or overload. The second one is fire and rescue operations. During night rescue, firefighters rely on portable thermal images to see through smokes and darkness. For example, firefighters in finding a trapped person in a burning buildings or locating in a forest fires to prevent flares up. The third one is building diagnostic. Thermal thermography Scans reveal hidden issues behind wall. It can prevent leaks in flat roof before they become visible water damage. And thermography also can spot damp spot inside walls that may cause mold growth. And builders and energy auditors can use thermography to report to plan repairs and improve energy efficiency. And the fourth one is security and military. Security and military use fixed thermal camera monitor sensitive borders, presence or restricted areas at night. For example, drones equipped with thermal cameras patrol pipelines or remote facilities for intruders or wildlife that could cause damage. Last but not least, detailed exploration on the medical thermography. For example, clinics use medical grade thermal cameras with strict calibration to detect vascular issues or abnormal metabolic activity, which is breast thermography can reveal increased blood flow due to tumors earlier than lumps are felt. Also, thermography also used by physiotherapists to monitor inflammation in sport injuries.
Free procedure that shows us heat patterns throughout your body using infrared imaging. We evaluate these patterns for abnormalities that may be signs of diseases like cancer and heart disease. Early detection is your best chance against disease, and medical thermography could be the answer you're looking for.
So for this slide, it shows the examples of real-world implementation of the thermography. Number one, thermography in medical. It helps the doctors find fever, infections, or even cancer without even touching the patient. Number two, thermography in electrical engineering. It helps the engineer to find hot or loose wires that could be dangerous. Number three, mechanical maintenance. Thermography helps to checks the machines to see if they might break soon. Number four, building inspection. Thermography works by finds the heat leaks, water problems, or poor insulation in buildings. Number five, firefighting. Thermography helps the firefighter to see hot spot or people in smoke-filled areas. Number six, environmental. It helps watches wildlife, checks plant health, or monitors volcanoes.
Here are two images related to the thermography. On my right side, the picture shows about house heat loss. It explains how heat enter the house and how heat exists to the house. There are certain percentage based on the material and the position of the house. On my left side, the picture show about fever screening image. It is used to detect temperature on a human. What is the potential benefit and challenge? The first benefit is non-contact and safe. It means no physical touch is needed, perfect for live wire, infectious patient or dangerous area. The second benefit is real-time detection. Heat doesn't hide, spot fire to smoke, catch machinery before it's failed, or screen fever in seconds. The first challenge is high cost. Top-tier thermal cameras are investment grade. It is hard for small team. But hey, the prices are dropping as tech evolve. The, the last challenge is it is limited to surface temperature. It cannot detect internal issue. It requires ultrasound or X-ray for full picture. Future development and innovation. The first one is AI power analysis. No more guessing, AI will instantly flag problem in medical scan, factory or building. The next one is smartphone thermal camera. It is affordable and also clip-on sensor will make thermal imaging mainstream. The third one is we can scan the entire solar farm or disaster zone in minutes. The next one is AR thermal version. Firefighters seeing through smoke, doctors spotting blood flow. Heat vision powered by augmented reality. The fifth one is climate smart tools. We can monitor crop health, track energy waste. It is sustainability meet precision. The last one is quantum sensor. It is accurate, low cost, and it is expected to be coming on 2035. Conclusion. Thermography turns invisible heat into useful information by capturing infrared radiation, and it is used in many fields. Because it works in real time and doesn't need physical contact, it is an important tool for medical diagnosis, checking industrial equipment, and monitoring the environment. Still, there are challenges like high cost, the need for training, and sensitivity to sounding that must be improved. The future looks promising too. With AI, smaller device, and augmented reality, tomography is becoming more accessible, faster, and smarter. As the technology advances, we will see it built into everyday gadget, opening up new possibilities, from preventing energy waste to helping save life in emergency.